Here's a limiting reactant problem that involves the excess reactant as well. So reading this out, we have ammonium and sulfuric acid, ammonia and sulfuric acid react to form ammonium sulfate. Remember, ammonium ion is NH4+. Write an equation for the reaction. Determine the starting mass of each reactant if 20.3 grams of ammonium sulfate is produced. So this is what we'll call our actual yield. But we have an excess amount of 5.89 grams of one of our reactant, that reactant being sulfuric acid. So we sort of have to backtrack or make a back calculation, so to speak, to determine how much of the limiting reactant was there versus how much of the excess reactant was there, realizing that this is how much that was left unreacted. So you got to remember the limiting reactant sets the limit. It's a reactant that sets the limit. So obviously something got all used up, and that happens to be the ammonia. It's the limiting reactant. And when it all got used up, this second reactant, sulfuric acid, had a remnant, and that remnant was 5.89 grams. So they are asking us to calculate the original amount of ammonia and how much it is the limiting and how much it reacted with sulfuric acid, which produced the actual yield of 20.3 grams. So ammonia is NH3 and sulfuric acid is H2SO4. That's our acids. Nomenclature on acids is something that watch the video on, but this is the formula for sulfuric acid, and they tell us in this problem that it gives us ammonium sulfate. Okay, ammonium sulfate is right here. Ammonium sulfate, the ammonium ion is NH4+. The sulfate ion from our flashcards is SO4 minus 2. We do the switcheroo with ionic compounds. The formula for ammonium sulfate is NH42 SO4 1. We got to balance this equation. So we have here 2 nitrogens and 8 hydrogens, 1 SO4. We got 1 SO4. Okay, we got 2 nitrogens here. So let's just make a 2 here to balance out our nitrogens. Hydrogens, we've got 6. 2 times 3, 6. 6 plus 2 is 8. How many hydrogens do we have here? We have 8. Okay, so 4 times 2 is 8. So this is a balanced chemical equation right here. And then 1 SO4 here, 1 SO4 here. So my products and my reactants are balanced. 20.3 grams of this product, ammonium sulfate, and the excess here is 5.89. Okay, so 5.89 is our excess. Keyword here is excess. How much limiting reactant was made and how much of the limiting reactant with this to yield this much excess. So this is the actual yield from this reaction, 20.3 grams. So 20.3 grams reacted, we assume, with all of the limiting, leaving this other reactant behind. So here is our limiting. So let's do our stoichiometry utilizing the balanced chemical equation to solve this. We got 20.3 grams of ammonium sulfate. A good first step is to convert to moles. So 1 mole of ammonium sulfate is 2 times N plus 8 times H, 1 S, and then 4 times oxygen. I'll do that quickly here on my calculator end, and I'm getting about, a very quick and dirty calculation, about 132.15 grams of NH4 All right. We know that for every 1 mole of NH4 2SO4 ammonium sulfate, there is 2 moles of NH3. This is our limiting, because the problem tells us this is the excess. And for every 1 mole of NH3, 17.04 grams are contained in 1 mole of ammonia, NH3. Okay, as before, we make a big emphasis on canceling out units. The grams of ammonium sulfate cancel. The moles of ammonium sulfate cancel. The moles and moles of ammonia, NH3, cancel. Doing this on my calculator, I'm getting about 5.24 grams of NH3. That is all gone. That is the limiting. So this is our limiting reagent, and it's totally consumed. So this is gone, produced 20.3 grams of this. Now how much of this reacts with that? Remember, this sets the limit. The limiting reactant sets the limit on everything, how much the excess reacts and how much of the product is produced. It sets the limit, so it's going to set the limit on how much of this reacted. So we'll calculate that, starting out with our limiting. 5.24 grams of NH3 times, we're going to kind of go a little bit reverse here, 1 mole of NH3, kind of backtracking, about 17.04 grams of NH3. All right, we know that for every 2 moles of NH3, there's 1 mole of H2SO4. Okay, that's a 2-to-1 relationship, getting about 98.07 grams. Your values may be close to this. They don't have to be exact. Everyone's periodic table is different. The grams of NH3 cancel with the grams, moles and moles cancel, and the moles and moles of H2SO4 cancel. Doing this on the calculator, on mine, I'm getting 30.21 grams of H2SO4. 30.21 grams of H2SO4 react completely with 5.24 grams of NH3. So what is the original amount? So the original amount is 5.24 grams of this reactant because it gets all used up. Originally, what you have is 30.21 plus the 5.89. So you gotta remember this. This reacted with all of this, but the problem tells you that 5.89 is left over. So how much was originally there? Originally was 30.21 plus the 5.89. So originally we will have the sum of these two, which is 36.10 grams. So that's the original amount that reacts with this NH3, leaving us behind with 5.89 grams excess as given to us in the problem.